In this presentation, we will look at the basics of wireless communication, understand the difference between RF and RFID, understand the working principle of RFID, examine some different types of tags used, look at the applications and interfacing possible. Radio frequency is a way of transmitting energy through empty space. That is, instead of using a wire or a cable. The energy is carried by invisible waves of electricity or magnetism that vibrate through the air at the speed of light. Over 100 years ago, radio came to mean audio programs beamed through the air by giant transmitters to wireless receivers in people's homes. When a new way was found to send pictures and audio, this was called television. Today, the same wireless technology is used in all kinds of communications, from digital radio and television, mobile phones, and wireless Ethernet. Radio and television send radio waves in one direction only, from the transmitter at the radio or TV station to the receiving radio or TV at your home. Wireless Ethernet and mobile phones are more sophisticated as they send two-way communication. Your mobile phone contains both a radio receiver and a radio transmitter, which allows two people to speak to each other in real time. Radar is another technology that uses radio waves. Planes or ships fitted with radar send out beams of radio waves and listen for echoes, which are the reflected radio beams bouncing back from other planes and ships nearby. A typical everyday application of radio frequency is the anti-shoplifting devices used in many stores. These stores will have a transmitter and a receiver at the doorway, and most items in the store will have a concealed RF tag. When a tag is passed through the doorway, the radio waves from the transmitter are picked up by the coiled metal antennae on the tag. This generates a tiny electrical current that makes the label transmit a new radio signal of its own at a very specific frequency. The receiver on the other side of the doorway picks up the radio signal that the tag transmits and sounds the alarm. If you had paid for the item, then you might have seen the cashier pass the item through a deactivating device, which may or may not have been part of the barcode scanner. This destroys or deactivates the electronic components in the RF tag so that it can no longer pick up or transmit a signal as you walk through the door. RF tags are the simplest tag type and are commonly used in store security. All the tags in the store are exactly the same, and none of them identify the articles to which they are attached. So when the alarm goes off, the mechanism doesn't know what's being stolen, only that something is being stolen, as there is no way of telling one item from another. They are popular in this application because they can be scanned at speed and at quite a distance. RF tags are sometimes known as transponders or chipless RFID tags. RFID tags operate in a similar manner but are more advanced than simple RF tags in that they can uniquely identify the item they are attached to. The radio signal that is sent from the tag to the receiver contains digitally encoded identifier stored in a microchip. The basic elements of an RFID system are a reader that is connected to or has a built-in antenna, an antenna that sends out the radio signal, a tag that returns the signal with the information added. An RFID reader, also called a transceiver, generates a high-frequency electromagnetic field that will power a tag when the tag comes close enough to the reader. A voltage is generated in the antenna coil of the tag, sometimes by inductive coupling, sometimes another way. The voltage will power the chip. The chip inside the tag then performs a logic operation and accesses some stored information. It will then reflect the received radio signal to the reader with a modulated voltage according to the protocol being used. The voltage changes are received as digital ones and zeros by the reader, and this is how they talk to each other. The reader is connected to some third-party system that will accept, store and respond to RFID-related events, such as a SCADA system or a PLC. Unlike RF tags, RFID tags work over much shorter distances, usually less than 10 centimeters. Simple RFID tags are described as being passive, which contain just an antenna and a microchip. They work entirely by responding to the radio waves from the reader, which powers the chip in the tag and also initiates the communication. There are also active tags which have a battery and some more advanced chips. These tags can send and receive information over more than 10 meters, according to the frequency, tag sensitivity, and antenna size. Both the reader and the tag will transmit radio signals at a certain frequency so that they can talk to each other. There are three main types of RFID signals: low frequency, LF, high frequency, HF, and ultra high frequency, UHF. Microwave systems are also available and generally used in road tolls. Most RFID tags do not contain any data after they are manufactured. They are like blank labels waiting for information to be printed on them. To place information on a tag, an RFID encoder must be used. This must be done using an RFID scanner with a built-in encoder and RFID encoding software. There are basically three types of tags called classes. Class 0. These tags are read-only and are encoded with data when they are manufactured. Class 1. These tags allow you to write data to the tag and are usually one-time programmable, OTP. These are available in HF or UHF and are known as Gen 1. Class 1, Gen 2 EPC. These are the latest type of UHF tag and are being widely adopted. They are generally referred to as Gen 2. They are rewritable, are 96 bits long or more, and have features such as lock after write and CRC checksum. An electronic product code, EPC, is a standard which aims to create a global standard for RFID tags. Within the new EPC standards, there are many different standards according to the industry and application. RFID tags generally hold less than 2 kilobits of data, which will include a unique identifier or serial number and an object class which identifies a group of objects. These fields are selected by the user. The header identifies the length, type, structure, version, and generation of the tag. The manager number is responsible for maintaining the user-defined information. These fields become predefined with the tag according to the industry or application. In retail, an RFID tag may be attached to an item like a pair of jeans. When a handheld reader scans an individual pair, this identifies the individual item from all the other identical pairs, as each item has its own unique serial number. Due to the object class field, this can also tell how many pairs are on the shelf and if more of this particular item are needed. In industry, RFID is common in discrete operations such as access control, personnel tracking, and supply chain management. Active tags have been inserted in the lighting power racks of miners' helmets. In this application, RFID readers have been used to connect to a Wi-Fi network which can locate personnel through a large area of underground tunnels. This greatly speeds up the location and activity at any one time and can send an alarm to control access to hazardous areas. In logistics, pallets of goods can be scanned easily from the floor to identify the necessary information, which can then be uploaded to a central database. One issue here is the problem of data flooding, where a pallet of goods being moved around on a forklift mistakenly passes a scanner. All this useless data is automatically sent to the database, which clogs up the system. Changes, such as adjusting the read range of scanners, can help, and software called middleware can be configured to identify unnecessary data before it reaches the database. Rail movements can be monitored easily by installing a single RFID reader to scan tags attached to rail wagons. These tags can contain the company information, load composition and source and destination of each wagon. When one reader is used, tags need to be attached to both sides of the wagon. Two axle counters, located 3 meters apart on the tracks, will detect wagons without tags and speed, direction and distance between the axles. Applications in continuous process operations are less common, but have been used in the iron ore industry. Tags which contain the ore quality information have been designed to be placed with the ore at the blast site and travel through crushers and conveyors to final blending. The tracking of different ore qualities on different conveyors has resulted in a more efficient blending process. Many popular vendors supply a complete system which will include an interface module that allows the scanners to talk directly to a higher level network, such as DeviceNet or Ethernet. If planning an RFID network, many issues need to be considered, such as reader antenna size. The larger the reader antenna is, the longer the distance it can read tags from. This is also called the antenna gain. If using a handheld reader, the reader can be offered up to the tag, so distance is not a problem, and size of the reader can be small. If the reader is in a fixed location and tags pass by it, the reader's antenna size can be increased to compensate for the increased distance to the tag. But there will be a size limit to the antenna according to each application. Reader antenna polarization. Reader antennas can be linear or circular. Linear antennas can read further distances, but only in one direction. Circular antennas can read tags in various orientations, but at shorter distances. Reader power. The reader's power can be set to high or low, which will increase or decrease the read range. Increasing the power may cause the reader to read multiple tags or other problems, so this may not be a quick fix. Also, doubling the power to the antenna does not double the distance of the read range. Tag size. Similar UHF tags can vary in read range from 1 meter to 12 meters based on the size of their antenna. Larger antennas have longer read ranges. Tag orientation. If the orientation of the tag cannot be controlled, this will be a problem for the reader's linear antenna. If the reader's antenna is circular, this is not a problem. Tag environment. If the tag is around a lot of metal, this will reduce the read range as metal will reflect the RF signal, causing interference. If the tag is in a high water environment, the water will absorb the RF signal and reduce the read range. Choosing the right tag for the application is important. Cables. Any distance over 6 meters will need to use shielded cable to avoid interference. The amount of connections and ports used should be minimized to avoid any loss of signal. Testing various combinations of tags, readers, and antennas in advance can minimize problems later, as every application has different challenges. Wireless communication uses radio frequencies to enable devices to talk to each other. This can be one-way, such as radio or TV, or two-way communication, such as Wi-Fi or mobile phones. Simple radio frequency, RF tags, emit a radio wave of a fixed frequency when activated by a transmitter. These signals cannot identify an individual item and are commonly used in retail security applications. RFID tags respond with a radio signal which has information digitally encoded in it. This can identify the individual item and other data such as source, destination, composition, etc. An RFID system will typically consist of a reader with an antenna and a tag. The tag will also contain an antenna to retransmit the signal and a chip to contain the information. RFID tags can be passive in that they are powered by the reader, or active in that they have a battery to power them. Passive tags have a short read range. Active tags have a longer read range. An encoder is used to write some types of tags. Reader antenna size, power, and polarization need to be correct for the application. Excessive water in the environment will absorb the reader signal and cause interference. Metal will reflect the signal before it reaches the tag. Correct tag types must be chosen. Cables should be shielded over 6 meters long and use of connectors and ports limited to reduce loss of signal.